Hello friends, welcome again to this channel. This is G Solutions. We find solutions for your needs. Now, we have here a problem. Let me read the problem. An industrial load of 200 kilowatt has a power factor of 0.5 lagging. So it is more inductive. And a group of synchronous motors operating at a power factor of 0.8 leading is installed, and the power factor improves to 0.75 lagging. So you are to determine the total kVA rating or the apparent power of the synchronous motors installed. So you know it already that we represent the load's power or the generator's power or the motor's power into a right triangle, wherein in that right triangle, okay, in that right triangle, okay, so there is the apparent power, the real power, and the reactive power. So here in this part is your theta, where you can get the power factor. Now, the given here is an industrial load. So we now represent the load into a right triangle. According to the given, it has a 200 kilowatt real power. So it means that it has this drawing. So this can be a leg of your right triangle, which gives us 200 kilowatts. Okay. And a power factor of 0.5 lagging. It means that 0.5 lagging, by the way, if you are going to get that theta for, let's say this is for the load, theta L. So the power factor is the cosine of theta. So the inverse cosine of 0.5, okay, 0.5, that will be the angle. So and it will give us, actually if you have your calculator, you just press it in your calculator, it will give you 60 degrees. So therefore, this triangle like this one, so let me just draw. Okay, so this is now the right triangle. So this is what you are what gives you 60 degree. Okay, so theta L. So let me just place here theta L. Okay, therefore we can easily solve here the apparent power here. Okay, so it's easy to get the apparent power there. Actually, we just have the cosine theta L. Theta L is actually the adjacent side, which is 200 kilowatts over S. Okay, so we get now S here. S is equals to 200 kilowatt over cosine theta L. Cosine theta L is actually cosine 60 degree, which is 0.5, no? So this is 0.5. So now if you have your calculator, again you press your calculator, it will give you 400 kilovolt ampere. That will be your apparent power here. Okay, now we will install a synchronous motor to be able for just to improve the power factor to 0.75. So it means that this theta L, you will make this to 0.75 lagging. So what is that 0.75 lagging? So let us have here, so, theta L and 0.75 lagging, or let us name that as theta improve or I. So that will be the inverse cosine of 0.75 lagging. So get your calculator and press it again. It will give you 41.41 degree. Okay, so it means that if this is 60 degree, it will come down, this will come down to 41.41. It is somewhere here. Okay, okay, so this is theta improve. Okay, now how did this happen? It happens because you introduce a synchronous motor to improve this part. This part is your reactive power. So this will be improved instead of having it here at maximum, where your S is 400 and 200 is your real power. It will just be here, and the motor installed will be placed here. So it will be placed here. The motor is also designated as a right triangle here. So you have here right triangle. Okay, so like this one. Okay, so the motor is probably here. Okay, so this is now your synchronous motor at right triangle. So this synchronous motor, okay, is operating at a power factor of 0.8 leading. So the power factor here, theta m, is leading. This is 0.8. So therefore I can also get the theta m. So theta m here is the cosine inverse of 0.8. Okay, and theta m will give us cosine inverse 0.8 is 36.87 degrees. So this is 36.87 degree, and okay, you are to determine, the question here is to determine the total kVA or the S of this synchronous motor. Let us name this as S sub n. So we are going to find that. What is the value of that? To be able for us to have an improved industrial load of 0.75 lagging up to this point. Okay, so this is again a triangle. So you are forming here now another triangle here. So to be able for us to solve this one, this SM, S sub m, so we are to use this triangle and perform the trigonometric analysis. Okay, so we know this already. We have a value for this. Actually, you can also know the value of this one. So since we have this triangle, okay, we can use our trigonometric principles and apply it here for this triangle. We know this already, this side, and also the angle here. We can know the angle here. Let's say this is theta sub x, okay, and the angle here also. Let's say this is theta sub y. We can know that, no? So let us solve for this, no? So if you know this one and you know this one, the angle here, theta sub y, and you know theta sub x, you can now know the side here, the SM, because we will apply the principle of sine rule. The sine rule, which state that A sine angle A is equals to B sine angle B. A here, small a, is the opposite side of the angle where you take the sine of. For example, if this is your B, then your angle here that you are considering is sine theta y. If this is the angle that you are, the side that you are referring to, the angle here will be this one, theta x. So in this case, we can use here S and then use sine theta y is equals to Sm sine theta x. Okay, so we have to get the value of theta x and theta y. We already know S. So what is theta x here? So theta x can be easily be determined, no? Okay, you can easily determine theta x. Okay, because this is 60 degree, this is theta L, which is 60 degree, and you subtract it with the theta I. Okay, so or the improved power factor. So therefore theta L is 60 degree minus 41.41 degree. So if you have your calculator, you just press your calculator and then you'll have an answer of 18.59 degree. Okay, so you already know this one. How about the theta y? So we are going to solve for the theta y. And this one here. So how do you find that one? Theta 1 here. So you will notice that okay, so we have you know that in a triangle, we have here a triangle here, yan. This is a triangle, an oblique triangle. The internal angles of a triangle is always 180 degree. Okay, so we can solve for theta y here. This is theta y. Okay, this is our theta y. Okay, so theta y, which is this part, is 180 degree. The angle, everyone here, you subtract the angle here, theta x. So what is that theta x? No? So you, okay, is it theta x? Yeah. So okay, so you have theta x, which is 18.59 degree. So this is it. 180 minus this angle and minus this angle. So what is the value of that angle? So you will notice that this part here is also a right triangle. So to be able to solve for the angle of this part, let's say this is theta prime. Okay, so theta prime, I will write it here, theta prime here is actually 90 degree minus theta m, and 90 degree minus theta m, which is 36.87 degree. So if you are going to have your calculator, so you have 90. Okay, so you can use your calculator. You have 90, okay, minus 36.87. Okay, it will give us 53.13. So this is 53.13 degree. That is your theta prime. So how about this one? So this is theta double prime. What what angle is that? We can easily get this angle from this part. So this is a right triangle. So you know that this part is theta L. So this one you can get theta prime. So theta prime, here I will write it here. Where? Okay, here. Theta prime is 90 degree minus theta L. And theta L, okay, is actually 41. No, this part theta L is 60 degree. Okay, so it will give us 30 degree. Okay, so therefore I can have now theta y here, because that will be 180 degree minus theta x here, and then this angle, all of this, so that is actually minus theta double prime plus theta single prime. Okay, so I just substitute 180 degree minus 18.59 degree minus, you have 53.13 plus 30. Okay, so you just have your calculator. Okay, it will give us, you press your calculator and it will give us an answer of 78.28 degrees. So that will be the value of your theta y. Now we are now to use this one. So S is already determined as 400 kVA is 2 sine. What is theta y here? That is 78.28. Okay, is equals to SM, which is what we are looking for, and then sine theta x. Theta x is 18.59. Okay, now we can now solve for SM. Okay, so if you press your calculator, I will not show it to you anymore, but you can solve it algebraically. Your SM value is 130.23. Okay, and the unit is kVA, kilovolt ampere. Okay, so this is the answer. We are looking for this one, the total kVA rating of the synchronous motor installed. This one, we have already find this part. Okay, so that is how you solve this kind of problem involving synchronous motor for power factor connections. Okay, but remember, in some problems we have an ideal capacitor in which there is no resistor involved. So this triangle will not be a triangle anymore. It will be a reactive power that is opposing this inductive power. So it's just a straight line going down. So again, thank you so much for watching this video. I hope I have contributed added learning to your learning desire. Thank you.